Hello everyone, I welcome you all in the series, another video in the series of daily lead code problem solving. And if you're new to the channel, you can subscribe to the channel. Here I upload in-depth video solutions of daily lead code challenge problems. And you can check out the previous questions. I've added the link of the playlist in the description box. You can connect with me on LinkedIn or Facebook. I've also added my profile link to my profile, and you can also get the source code of these solutions. I've added the link to the GitHub page where you can find the solutions. So let us see today's problem. So again, it is a n queen problem too. So before this there was a problem just n queen. So this is the next version of this problem, right? uh, both problems are exactly similar. I would say 99% they are the same problem. There's just a small difference in this problem, what we need to do. So I have explained solution of this problem in a great detail. You can check out the video. I've also added the link to this video in the description. And the video is already, I've gotten a very positive feedback. The people are able to understand the solution very well. So you can check out video of this solution and then you can come here, because in this solution I'll be assuming that you know how we have solved the n queen problem, and on the top of that I will build this solution. Okay, and I'm also going to take the same code which I coded in the n queen problem, and I'll just modify that code a little to solve this problem. So the problem is that again, given the n queens and given the n queens, and there will be n cross n board, and we need to put these queens in that board and such that no queen attacks each other. So you can understand each and everything in that video. So this time what we need to do, we need to return the number of distinct solution this have, the number of different kind of you can say the number of different ways in which I can place these n queens. So this time I need to return the number of ways. Last time what I was needed to return is that actually the configuration of that different ways, right? Actual how that board looks like. So this time we just need to return the count. So let us build this solution. It has the same constraint as before. So if I show you, this was the code which we had coded last time. So I'm going to take much of the code from here only. So I do not require this list because here I was storing all those different combinations, all those different ways in which I could place coins. So this time I do not require this. I just need that count. So first of all, I need this. And then these were my functions which were giving me the solutions. Let me just copy this as well. So now in that previous code, what my DFS function was doing, it was writing this board configuration. If it found that we have placed all the endpoints, then for that current configuration of that board, it was putting that entire row, a replica of that entire row into this list of list. So now we do not need to do this. If it happens that we have placed all the queens, then we need to say that yes, I have found one configuration. And what we can simply do, I'll show you one of the easiest way to count this thing. We can take a global variable, right? Count. Actually, this is not the very best practice to do, but let me start with this approach, and then we can go and write a better technique to to solve these kind of problems. So what I'm doing right now, I'm just taking a global variable count, which returns the which actually stores the total number of count, which in which I can place the n queens such that no queen attacks each other. So here in this function, if I have encountered this condition, that means I have found a solution. I have placed n queens such that no one is attacking each other. That means I'll just increase the count, right? This global variables count, and I'll simply return back because I have done the job. I have increased the count, and I'll go back from where the function this TFS was called. We need to also do few little things here. We do not require both variable now here because we are not storing anything here. And again, in this function, this will remain the same. And what now I am doing, I'm not passing this value. That is all. And that is all I'm doing. And when this all get finished, I'll just return the count, right? So let us see if it is working. Yes, it is working. Let us check for all the cases. Okay, so the solution will be accepted. Let us submit this solution. Okay, it is getting accepted. And now what I was saying earlier, that we should not use a global variable, right? The reason is that when, let's say, we are working on an actual project, and if we store everything in a global variable, then uh, when you will call when you will reuse your function, because many a time you need this value to be resetted, right? So we prefer that these variables should be a part of the local function which uses these variables. Otherwise, if it was a global variable, and if I'm using this global variable into some local function, then there will be some previous value returned to this. I might forget to reset this value somewhere, and then the whole code will be burst out. Okay, so it is not a very good practice to create a global variable. So now see what I am going to do. I will say my DFS function itself returns the count. If I'm starting at this ith row, then from the ith row, what are the total number of solutions I can build? This DFS function itself returns that. Okay. Now we do not need to return this count this time, and the DFS function returns. Now the return type becomes int. Okay, so now when it encounters that row is equals to board.length, that means the solution has been built. So this means uh, this is one of the way, the current board configuration is one of the way to build the solution, right? So this will return one to the function from where this DFS was called, right? Then from definitely it would have called from somewhere here, right? Or let's say the board was only a 0 x 0, let's say 1 x 1 board. Okay, you will get better understanding what I'm doing here. Let me show you. So let's say the board was just a 1 x 1 board, right? 1 x 1. So I can easily place the queen here, right? And this is the last row. So if I see here that I'll be starting from this, if DFS was called at 0th row, I'll come here, and if I will check if I can place my queen here or not. Then everything will be true, and this all condition will be true, and I'll place the queen and call DFS on the first row. And since there is not the first row, uh, in the next call, this condition will be met true, and this will return 1 to this position. That means if I start at row +1, so there can be one solution which I can build, and then go on, check, iterate on the next column, and then again calculate from the next row and see how many number of solution you can build. So while starting from each column, you'll call this function for the next row, and that will return the number of ways. If you have chosen this column and this row plus one, so this will return the number of ways you can put. So you need to accumulate all the count, right? So I'll say let the count is equals to 0, and I'll do this count plus equals to DFS of this. This will simply add on the value to the count. If the j was 0 and at j0 I was able to place this queen, then I'll build the solution from the next row when I had placed the queen at 0th location. So what was the number of ways? So this DFS function will return that number of ways. I'll add this ways to the count variable. Then I empty this cell. Then again, I go to the next column. I'll check if I can place the queen at this column. Then again, I'll call this DFS function in the next row, and I'll I'll also get the answer that what are the number of ways again I can put the queens, and that number of ways count will be added to this previous count variable, right? So in this way, all those different number of ways will be added to this variable, and finally when I'm done with all the columns, I'll return this column because we have already accumulated all the sum, right? And this count will be returned to this position, and this will return this value. Let us check this. Okay, it is working for all the test cases, right? I've already written all the test cases. Let us submit the solution. Okay, so it is getting accepted. So I hope you have got the concept, and it is very must to understand the previous problem. So I've added that link. You can check out first that video, and then you can come back here, and this will be this will sound very easy to you after that. So I hope to see you in the next video. That is it for this video. Thanks for watching. See you later.